quantity of ethanol was heated until it reached boiling point. We're told that the temperature of ethanol, which is denoted by theta and is measured in degrees C, at time t seconds after heating began, is modelled by the following equation. So this equation says that we have theta is equal to A minus B multiplied by e to the power of negative 0.07 multiplied by t, and that's where A and B are positive constants. We're given two pieces of information here. We're told firstly that the initial temperature of the ethanol was 18 degrees C, and that after 10 seconds, the temperature of the ethanol was 44 degrees C. So we are asked to use this information to find a complete equation for the model, and we're told to give the values of A and B to three significant figures. So what do we want to do here? So essentially, we're given some information and we need to complete the equation. And when the question says complete the equation, what does this mean? So this means that we want to find the values of A and B. So find these constant values. So how are we going to do this? So our first step is going to be to set t equal to 0. And when t is equal to 0, we know that theta, so the temperature of the ethanol, is going to be equal to 18. So we have this from this first bullet point of information here. So therefore, this will give us the following equation. So we can substitute this into this equation here, and we'll have that 18 is going to be equal to the constant A, and we take away the constant B multiplied by the exponential function to the power of negative 0.07 multiplied by 0. So then we can just tidy this up a little bit. We know that we have A minus B to the power of 0 because this exponential power here is going to be 0. And we know what happens when we have e to the power of 0. So we'll just write this here. We have e to the power of 0 is going to be equal to 1. So therefore, this leaves us with the following equation. We have that 18 is equal to A minus B. So we'll now use the second bullet point of information. So we have that when t is equal to 10, we have that theta is going to be equal to 44. So this means we can just do the same again, and we can say that 44 is going to be equal to A minus B. Apart from this time, we're going to have something slightly different. We're going to have negative 0.07 multiplied by the time, which is 10. So what we're going to do is just shuffle along our decimal point by 1, and we'll have negative 0.7. So therefore, we now have two equations, and we have two constants, A and B. So we can now use our knowledge of simultaneous equations to solve for these constants. So we'll now rewrite them both in terms of B by making their subject equal to A. So for our first equation, which is this equation here, we'll have that A is going to be equal to B plus 18. We get that by adding B to both sides. And secondly, we have that A is going to be equal to, so we'll have B multiplied by e to the power of negative 0.7. Then we add on 44. So this is our two equations. We can now set these equal to each other. So this part here and this part here, they're going to be equal. So we can therefore say that B plus 18 is going to be equal to B multiplied by the exponential to the power of negative 0.7 plus 44. So tidying this up a little bit, we can take our b's onto the same side. So we'll therefore have b, and then we subtract b lots of the exponential to the power of 0.7, and that is going to be equal to 44 take away 18, which is 26. And we must remember what we want to do here. We're solving for b. So we can therefore take a common factor. So we'll have take b out, that's going to be 1 minus e to the power of negative 0.7, and that's equal to 26. We can now see that we're not far from isolating this b term, and we can do this by dividing both sides by what is in the brackets here. So therefore, we can say that b is going to be equal to 26, and we divide that by 1 minus e to the negative 0.7. And what we can do is we can put this into our calculator, and this comes out as 51.647 and so on. So therefore, like the question asked for, we're asked to give these values to three significant figures. So we can say that b is going to be equal to 51.6. So now we've found out the value of b. This makes it relatively straightforward to work out the value of a. So what we'll do is we will take this equation here. So we'll just draw a down arrow here. And we can now say we know that b is equal to 51.6. So therefore, we'll have that a is going to be equal to 51.6 plus 18. And what is this going to be equal to? This is going to be equal to 69.6. And we know that is equal to a. So now all that's left us to do is to take this original equation we had and to rewrite it, but with our values of a and b. So we can therefore conclude that theta is going to be equal to our value of a, so 69.6, and then we subtract our value b, so 51.6, and then we have that is multiplied by e to the power of negative 0.07, and we multiply that by t. And that's us completed part A of this question. So looking back at this question, there was 4 marks available. We receive our first mark for knowing to use the information we were given and setting t equals to 0 and theta equals 18 and substituting this in. So we receive our first mark here. And we get that for either doing it with t equals 0 or t equals 10. And then we pick up our second mark at the point where we did both of these substitutions. So we did t equals 0 and followed it through, and t equals 10 and followed it through. So we pick up our second mark just here. We then pick up our third mark for calculating our first value of our constant. So we received it when we calculated b. So that was when we got that b was equal to 51.6. And we then received our fourth and final mark for following through to calculate our second constant and substituting it into our equation to have the final answer. And that's us completed part A of this question. So in part B of this question, we're given some information about the boiling point of ethanol. We're told that it has a boiling point of approximately 78 degrees C. And we're asked to use this information to evaluate the model. So what I've done here is I've copied down our model from part A. So we can see here that we have 69.6. That was our constant which we found. It was our constant A. And then we have this value, and we're always going to be taking away this part, which is always going to leave us with, in the end, a theta, which is less than 69.6. So this is where we run into an issue. So what does it tell us? This tells us that the maximum possible value of theta is going to be 69.6. And this is because this part here is always going to take away from 69.6. So just writing that down, we can say that the maximum temperature is going to be 69.6 degrees C according to the model. So then in practice, what does this mean? This means that the model isn't great. And why is this? This is because the maximum should be 78, because that is the boiling point of ethanol. So therefore, this is a fault in our model. So we'll just write this down, and we'll say that, therefore, the model is not appropriate. And why is this? This is because 69.6 is much lower than 78. So therefore, this question is worth 2 marks. We receive our first mark for kind of looking at the model and identifying that the maximum value theta can take is 69.6. And then we receive our second mark for linking this to the problem we have, which is that the ethanol has a boiling point of approximately 78 degrees C, and hence concluding that the model is not appropriate. So we receive that second mark just on our second line of work here, and that's us completed this question.